Pushing buttons. There we go. Microphone was flaking out. Everybody here now? Hello, Otel. Welcome. Today we're going to be continuing our game dev project that I forgot to put messages on other social media. Oh well. Before we get into that, though, let's check in with the kitties. We do have all 5 visible right now. We have Sammy taking over the tree. We have Ember in her spot. Sky over on the side of the desk here. And then Mason and Sherbet on the bed. All 5 good times. So when last we left off, over here. So when last we left off, we got the shader working. As in, it runs relatively swiftly. And it doesn't eat GPU resources. Which is good. Well, it doesn't leak GPU resources. So now we have to apply this to actual collision. And we also want to maximize general efficiency of this. So what we want to do is get the combination of the local size and the dispatch size, the number of work groups and how many iterations those work groups handle. We want to get that up there to cover the entire data set. Parakeet and I were going over some ideas, and Parakeet proposed an interesting path here. We're going to want to check that, but right here where we dispatch, so we want to come up with a pattern that will maximize what we can deal with here, but that will still follow our data pattern. To speed it up the most, we want to cover the equivalent of 10 million things with our data group. And I believe... So, 32 is... what would it be? From what I could tell, and from Parakeet's suggestion, but from what I could tell as far as looking into it, 32 is the size of dispatches that the NVIDIA likes to do. I think it's 64 on AMD. I don't know if that's changed since the information that I found. As is tradition on the internet, good luck with temporal accuracy. So we're going to break that into pieces here. So our number here will get us to type. Interestingly, 100,000 actually divides cleanly by 32. 3125. It was weird. So if we were to do it this way, then what we will get is about 10 million iterations, which isn't quite up to the number, but we could just this is kind of where we're figuring it out. We're figuring out how to get the number we want. Oh, that's right. We need 10 billion. And that's where the extra 1024 comes in. Yeah, there we go. Okay. I was missing that. Thanks, Lane. Oh, find all my buttons here. Okay, so this is going to get us to about 9 million. And then in the actual shader, each one of those 9 million is going to do 1024. So there's going to be a lot going on here. We're going to need to piece the data together properly. What we want to have happen is that each one of the iterations is going to cover 1024 of the values, and we're going to do that 300. So let's go through it here. So X, Y, and Z, they are a nested for loop. So 3,125 times, we are going to do 3,125 times 1 executions of this guy, and within this, it will do 1,024 iterations. So that'll get us to our 10 billion, which is our 100,000 squared here. Math. Yes. 10 billion. So then we need to convert this. So what we're doing with this then is that every iteration will be dealing with one pair. So one instance of each. Let's check something here. Not quite. I think if there's a better way we could go about this, because no. So we have to math it out here. What we have to do is get this translated over. So we are going to have access to all of these values. We have access to a global index, essentially. Let me see if I can find what that variable is called. We essentially have like iteration IDs. I am concealing this because the page is white. Because otherwise it'll do things like this. Okay. I think we're checking some variables here. Okay. So here's our tricky element amongst them. So we have the indices. If we have global workspace ID X, Y, and Z, each one of these will scale accordingly. So I need to show the math here, so prepare your retinas. So all of these things that we're dealing with are three-dimensional vectors. That's where the XYZ comes in. We're using these smaller numbers because we have limits on what each of them can be. So the local size can only multiply out to be 1024. And the upper size has limits based on GPU, but like X can go up to 65,000, and then the other ones have other limits. But that's why we're using 3125. Both of those are below that and will get us pretty far along. But we have to figure out how to translate the values that we get into positions in the array. So we need that XY positioning sort of thing. And that will mean getting like a final number. So again, we're going to get a vector 3, an unsigned int vector 3. And each of those values is going to be based on what we have here. All right, let's see here. Okay. Let me run the calculator here. Parakeet is helping us with math. Each X we're going to have. Yeah. Okay. So what we'll be able to do is look at our workgroup ID. Then I think let me close some of these because I keep reopening them. Okay. So within the work group, we're going to have 0 to 32 or 31 in the XY. And similarly, we're going to have 0 to 3,124 in the actual work group IDs. So it should be that we can get as our work group ID. This should get us what we need, our global invocation ID. Should. It'll be great. I think we're already using it here, or at least. Yeah, there we go. So we'll use this to get our XY. Got that. So this will give us the equivalent of 0 to 99,999. So we will be able to have the index of the one being compared. The index of the one that is doing the colliding and the possible collidees. We're still going to keep collision count buffer. We'll need that in a moment. I could be using structs. We could absolutely be using structs. There's probably going to be optimization or tweaking later. For the time being, lots of buffers. Collisions buffer is going to be structured as before. There will be there are X values possible for each one, so each can only have so many collisions. We're going to need to pass in some of those variables, though. And that's where we're going to have to change the buffer. So, this is stream of consciousness, folks. If it sounds like it's gibberish because you don't know code, that's fine. We chat as much as anything. So feel free to pop in, ask questions, whatever you like. If you have questions about the code, feel free to ask them. We're all learning together, especially with this. On top of this being the first game I've ever made, this is also the first time I've played with compute shaders, let alone shaders in general. I thought I had left C-style coding behind. C++ is a terrible and dangerous place. Okay, let's... We're just going to put some markers here. So first, is it active? Then we can have an end in here. But we're just going to nest ifs. Ultimately, it will compile down to the same thing. Sort of. I'm going for legibility more than anything. So these are both active. So we care that there's a possible collision. Then we're going to check the mask. And if that works, we'll check the collision. And then if that functions, we are going to try to add to, which is so we see, are they active? Hopefully we never get that far. You know, there's always a programmer somewhere. Usually within an organization, within any given team, that is the one that thinks that there is a particular language, usually a language that is essentially obscure or foreign to the platforms you're using, that would optimize things. And all it would require is that everybody train extensively to learn to write in a new language, and that the entire program base would be rewritten to account for that language, whether it be directly rewritten or rewritten in a way that it could actually run that language in addition. Beverage. Oh, that's a flavor. Okay, so if they're both active, then we're going to check and say, is this a type of, is the entity that we've got, does it care about the entity that we're looking at? So effectively, they both exist and are accepting collisions. And then, do they care about each other? So is the type of the target entity within the mask of the entity that we're checking about here. Then we will do very simple positional logic here, which is get the distance between the two. Source position minus target position. So the projectile in question, the object in question position. I'm sorry, the target position minus the source position there. Then we calculate out the length. We'll use length squared just because it's more straightforward and we don't have to do a square root. And we find out, is it less than or equal to the longest of the radii of it squared? So, if there's one of them that's 10 big and the other that's 5 big as far as radius, then we only care about the 10. Again, very naive collision check. It doesn't account for movement during the frame. It only cares about at the moment of the snapshot. Did they overlap? If they did, then we're going to try to add it to the collision list. And the first thing we'll do, something we are trying today that we haven't tested, but we're going to do an atomic add. And an atomic add essentially says, well, it's kind of like a semaphore in threading, in that anybody else that gets to that point has to wait for it, So a given entity will try to touch it. Everything else has to wait for it. And what we'll get is, we will get the current value, and the value will be incremented by 1, or by however much we requested, but it will be incremented by 1. And that is that would be the size of the collision collection. If it's bigger than the maximum allowed, if the result is bigger, then we're not going to allow it to happen. We can make that check at the beginning. If we've already hit max collisions, we're going to stop right at the beginning. Doesn't matter if they're active or not, just skip. So then we try to add it to the list. We will have already stopped here if the list is already full, but it's possible that another one, by the time we got here, one of the other work groups or iterations within a work group hit this and already incremented it. So we check again after we've added it and say, okay, is the new value less than or equal to maximum? If it is, we then take the original value before we added 1 and use that as the index, the offset index in the collisions. So right now I think we were going with like 100 maximum collisions. It could be as low as like 10 or something like that, but let's go to our edge case and say that in any given physics frame, right now 30 times a second, a given object is allowed to collide with 100 other things. If we had walls, then we would have to do more complex logic here, because solid objects would need to have supremacy as far as collisions. If you hit a wall, you hit a wall. You don't get to pass through it. Therein lies speed running. So we'll see if we can add it to the collection. If we can, we've got an index. We use the index. We store that off. In this case, it's just going to be a number. This one collided with that one. If we want more complicated collisions later, then we make the collision a struct and we add stuff. So it could be like the center of the overlap is here kind of stuff. So as of this frame, this is the center of the collision that occurred kind of stuff. I think this drink has gone bad. That's odd. Okay. So we'll do this until it either fills up or otherwise. Because we're going to use atomic add on collision count buffer, it cannot be write only. An atomic add is a read and a write. But the actual collisions buffer can be write only. Because we will only output to that one. Now, one of the consequences of that is we do need to flush this thing each time and reset it to 0. Because we cannot guarantee any one of them will be the first one to get in there. I wonder, is there just an atomic set? Nah, that would be wasteful. It will just keep doing that. We'll do that before it goes in. We'll just recreate the collision count. It's not the best, but I'm sure we can make it work for the time being. So we have our active buffer. We're going to bump all these down by 1, and we're going to make binding 0 effectively our rules collection. All right, there's our cleanup. So we'll have another RID that we'll make. Yeah. And we don't want them doing something unless they absolutely have to. Like you mentioned at the end of the last stream there, Parakeet, while it is fast memory, if we're doing things the equivalent of 10 billion times, it adds up quick. But we don't want them doing things unless they absolutely have to do a thing. The compute shader. Sorry for the moments of silence. Every now and then I've got to concentrate a little bit more here. all of these are part of this thing. We need to be cautious here because we want it to be in multiples of 32 that we're dealing with. This is going to be something that is a maintenance issue. Go into our entity manager for the time being. Is that ideal? No. People disregard comments all the time. One of the things I had to deal with in the past trying to think of how to make this coherent. I kind of want to have this because then it's kind of built in. What we're doing. But I don't necessarily want to have... I don't want to make assumptions about this, but I think we have to. Hello, Billboard. Welcome. Yeah, let's do that. This is crude. We are doing this in other places. As in, we're replicating this math, but we're being explicit about this. Well, we've missed a lot of broadcasts, so you might not have missed as many as you would, as might have been, Billboard. I don't recall. Which advice was it, Billboard? Which words of wisdom were actually wise words? Would that actually work, Parakeet? Ah, okay. Because we need 3125 for this to pan out. That is true. We don't want it to be... We don't want it to be sub 1. Because it needs to... Well... Yeah. Needs to run at least once. And then within... I mean, wouldn't that be the equivalent there? Get a lot of extra invocations there, but it's still going to go in as an unsigned int. That is true. It does want it to be dispatched in 32s, but that should be... Yeah. Won't let us get away with that. Syntax. Okay. There we go. know the number of entities and the number of collisions. So if we know the number of entities, then we know where to stop. But we always know where to stop based on the size of the array coming in. So we can always just check that. So we don't need a max entities. Any of the buffers will be that big. So we need to know the maximum number of collisions so that we can offset it properly when we're outputting. Yeah. Okay. Need any other rules? Don't think so. So is it active? Unit uint. That will error in a couple of places now, but byte collection and then okay. Fat-fingered copy again. Okay, so then we have our mask. And what we need to do, what we'll be doing is when we get to that particular index on the X side, we are going to see if the type or the mask. So is there an overlap between those? If it's greater than 0, then we have a valid collision or a possible valid collision. So buffer type or active type position radius. We need to get our type. We need to get our bytes buffers in here. Again, all of this could be a struct, but I kind of don't want to have to deal with the whole sizing thing, because if you get it wrong, the same thing happens as what happened with our trying to use active as a Boolean, is the memory will be wrong. But if we use everything as an int or a float, then we have the basic atomic unit, and we don't have to worry about it. Now, I could make this a vector too. Nah. Ultimately, it's resulting in some of the same things for now, so... Okay. So we're going to add these to the cleanup first. And then we'll proceed into configuring them. And one of the configurations on this has to be that we zero out collision count data. I mean, we could just have an equivalent one sitting around. I might do that. So I might have an int array that is pre-populated with nothing but zeros. And then when we are updating, like when we're getting the data back, we will take the output bytes and we will put them into collision count data. But when we're putting it back in, when we're updating the buffer, we will take the zeroed out array and we will use that to marshal into the bytes. Yeah. So now we need to set up our extras here. So we have our active, we need our collision type, our collision mask. Make sure we've got the others in place too. Is entity manager. So that little extra add-on there where it wanted to make a second dimension to the array is, again, the reason that you can't trust AI to code. Apparently, you're starting to get open source project managers complaining about people doing AI tests on their code and having the AI that they're letting do the coding for them report errors, and then having AI generate error reports and submit them as issues to the open source project and reply to those issues. Because there are not coders who can't even be bothered to not code. No, it's not active bytes, it's collision type bytes. So equal to bytes, collision type data. As span to array. Yep. Then collision and buffer, rendering device dot storage buffer create. As a unsigned int. Bytes. I can totally spell my variables. totally spell my variables. We also need our rules one here. Okay, we have defined a structure there. We're going to do this as a struct because I don't want to make buffers for every single one of our little rules. It's different when I'm making 10,000 long data arrays. Just a C# syntax thing going on here. Can't use it as a type name in the same place that we're defining it as a type. I could move this outside of the actual type. But we're not gonna. Need to do that. Syntax. Should be shader rules.max collisions. Shader riles. Is a type. It's been defined. Am I missing here? Well, we'll take our break and we'll be right back. All right. These are all defined inside of a shader collisions components class, and there is a why does it have to be a this? Weird. Just code syntax stuff. Okay. ID. Storage. Storage buffer create. If hmm. I know we have an example of somebody doing something like this. Checking, checking, checking. Seeing if I can find it. is binding 0. Settings. Okay, they're just doing it as a byte array. Okay. Looking at our example code again. So instead of a struct, we are going to have... We are going to... Oh, let's see here. Bytes will return a span, which will be as span array. There. Then all right, so we've set up the bytes buffer here, or we're setting it up. This one never needs to be updated when we go through that. Active is 1, collision type. Its collision mask is the next buffer. Okay, so type is, again, it's going to be like bullet, player, enemy. Mask is going to be what those look for. Currently, mask is only one thing. So the player looks for nothing. Its mask is 0. The player collides with nothing. Bullets look for enemies. Bullets only collide with enemies, nothing else. Enemies look for the player. An enemy will only collide with the player. Now, notice that I didn't say that enemies collide with a bullet. It's because an enemy doesn't run into a bullet runs into an enemy. It is a collision in one direction. Mask. Anybody old enough to remember a series of toys during the era when children's cartoons were advertisements for toys called Mask? I believe it ran in similar time slots to Gem and the Holograms, which you will not recognize unless you recognize what I'm already talking about. Mask, then X, Y, radius, count in data. Four, 5, 6, 7, 8. Double check. 0, 1, 2, 5, 6, 7, and 8. Okay. Now we're going to go to our cleanup here. Let's see. Rendering device .free RID. Bytes is equal to null. Click those out. Let's do this in order here. This will be buffer. And This will be our collision mask. Buffer. Then we need our bytes is equal to position y bytes is equal to null. Okay, so we're cleaning them all up. So this is when we get the data back. We only care about the count bytes and the collisions bytes. Byte array, which is entity manager, max entities long, passed in there's a syntax for this to pass in nothing but zeros. Might be overthinking this. Oh, I know I did this somewhere else and I've forgotten where I did it, so. I can predefine it explicitly. Well, we'll do it. We'll use the brute forcey method for the time being. The reason I'm doing this, the reason I'm bothering doing this, is I don't want to keep reallocating this array. So we're doing the same thing. This will be zeros. Should be uints as well. Okay. So this is where we retrieve the data out. This is where we update it. What we're going to do is when we initialize this one, again, there's got to be a better way for us to set this up, but I don't know what it is, so we're just going to iterate over the whole thing, and we are going to say, actually, no, we don't need to. We don't need to. As of this moment, I have duplicated it over. So this is an empty byte array of the length of the proportional length that we need. So 400,000 bytes. So then when I'm updating collision count data, when I'm updating that buffer, I'm going to use collision count bytes zeroed instead of the regular one. We are using an empty one. This should work. Span. So here's active. And we need each one of the others. So we're going to go through. We have active, we have the mask, we have the position, we have the radius. Okay. Partial. Data span. Now we're going to update the buffer. Yep, I know. Which type buffer, have no offset. You're not actually being helpful. Okay, so we need to update type, mask, active, all of that, because all of that can change frame by frame. I feel like we should throw artisanal in there to, bespoke artisanal kinetic energy swaps. There's some other buzzwords I feel like we could throw in there. Oh, locally sourced. Locally sourced bespoke artisanal kinetic energy swaps. That's a nice one. 5 names. Hello, Jose. Sizzling. Well, we are in the midst of setting up buffers for our compute shader that is going to handle collision detection for us. If you don't follow that, don't worry about it. You don't have to be technical if you just want to chat. I feel like that would be something, I mean, I feel like I should encapsulate this. Now that you mention it. Buffer, it has a oh, but no. Yeah, we could do that. Template functions. What's the syntax for this? Let's look it up. Okay. So he is not null. That's not quite the same. Has to be a non-nullable type. Oh, well, we're learning. We're learning. Syntax. Where it has to be a class, but it's not what we want. Ah. No, no. Unmanaged doesn't seem to be what we would want here. Hoping Reddit can help us, but so far it is not. Okay. So it seems that there is a way to do this, but I don't know that we want to. I'm trying to make a function to update the buffer. Right now, everything is a uint, so I can probably get away with this. Okay. There. Now we have update buffer. Burn. We're getting there. We're getting there. So all of these should essentially call get bytes from data on theirs and then update buffer, with the exception of the zeroed one. Data, which will be okay. So this should be the equivalent of that. Buffer collision type data. See, much more concise. Buffer. Also saves me the hassle of getting this wrong repeatedly. This one is different, and this is kind of the reason that we even did this. That one's different. Because whenever we update the mask buffer... No, wait. We need to get the radius in here, too. That's mask data. That one's correct. Then we are going to take this one down here. Okay, no, that's correct. It's different buffer, though. There. That's what confused me. This one is different. The count buffer always passes in the 0. It will retrieve whatever was there and parse it accordingly back into the data so we can operate on it. But whenever it updates the buffer to deal with it, it will use the 0'd one. Let's go to this data here. I mean, we could have a 0'd one here too. Let's do that. Okay, I messed up something. That's why. I just spelled it wrong. Yeah, this should work. Totally. Doesn't hurt, really, that these weren't the right things, but... Radius, okay. We need to update the radius. Oh, okay. This is the different one. There is like I said, there is supposedly a way to do this. That you could use an abstract type. There's a particular interface, apparently. Just not going to mess with that just yet. Never need to update the rules buffer because that never changes. Okay. So now we need to go into here and make sure we've got the markers set properly. So collisions data and collisions count are 8 and 7 respectively. Active buffer is 1. Unit data, this is we need this so that we can actually parse it while we're running here. Then this is binding 0. So now begins the slow iteration over the buffers to get them into the shader so that we can do the actual checks that we want to do. Okay, so this is collision type. Type. And then this is our mask. The next one should be position X and Y. Okay, I missed one down here. Missed 2 down here, yeah. XY radius. This is another thing that we could just put in a function. Same with this. Okay, we've got the buffers ready here. Mask, then X, then Y, then radius. Float. Y is 5. Radius is 6. Just posture. Okay, and we won't be changing rules active, collision type, collision mask, X or Y, but we will be technically be well, we will be reading and writing to collision count buffer. We're only reading from it because we need to do an atomic operation on it. We are only writing to collisions buffer. Okay. Okay. If this is the active buffer, it is collision type buffer and collision mask buffer. X, and then we're going to do an OR. On Y. Okay, so we're going to say is the object being operated on here, is it looking for the type of the object we're looking at? Sorry. The one that is colliding, is it looking for the type of the object potentially being collided with? If it is, then we do all this stuff. You know what? This is ultimately the same thing, but, you know. Let's see. Checking some data types here on very white pages. Okay, Vec2. Should be able to do this as... that up again. Different thing. It's just float data though. At the other one. Voids. Data buffer. Using them as paired ones. We can just brute force this part. This is equal to y minus x y buffer to all right, so we have the xy from our source to the target. And this is going to be squared. Because we're going to do some Pythagorean here and say that the square of the x and the y each added together is equal to the square of the line directly to. Geometry, I believe I'm right. So if equal to radius buffer data radius data buffer. X is greater than y. That, else we'll do this. Times that. Sure we get these semicolons in here before it blows up in our faces later. I could make methods for these, but we're not gonna just yet. That and we're only doing it once, so Okay, so what we're doing here, we are getting the vector from the current x coordinate object or x iteration object, and we are comparing it to the y iteration object. I'm sorry, from the x to the y. So it is the y coordinate object position minus the x position one. And we're doing this one variable at a time. This doesn't need to be a vector 2, but it is. Then we get the square. We square the x and the y of that vector and add them together to get the square of the distance from our x object to our y object. Then we determine which is the biggest radius of them. 6 one way, half a dozen the other, but we get the biggest radius, and the biggest radius squared, and we compare it to the distance. If the distance is less than or equal to the radius, then we've got a collision. Oh, yeah. Good point. Good point. It's also easier math. Good catch. Good catch. Okay, so then what that syntax is here. Yeah, this is a bright white page, so okay, so in theory, it's going to be this. How to spell it almost immediately. There we go. Atomic add. So it's our data here, which is going to be our collision. Okay, so we're going to do an atomic add here. What this is going to do is, one, it's going to wait until nobody else is doing this operation within this shader run. It is going to get the current value of this, so what the current collision count is. It's going to add 1 to it and return the original value. Okay. Okay, so the collision index is what we would use. Is collision count buffer. Okay, if this is still less than rules buffer dot max collisions, then this is where max collisions comes into play as well. Oh, yeah. Collisions. The collisions buffer is an array of collision counts. Like, it's multiplied out. So it's a max entities times max collisions sized array. So it will be max entities memory chunks of max collision size. So it would be let's just parse this out. Equal to the collision index times buffer max collision plus collision index. Right? No. This. Yes, max collisions per entity. Read as, this is the big buffer. This thing's like 40 megs. It's collisions buffer. Equal to that. Hey there, food. Welcome. We are in the process of getting our compute shader that brute forces our collision detection working. If do I know the world of HTML? I am aware of HTML and I've used HTML before. I'm not terribly fond of the ecosystem because it's a bit let's say non-deterministic. There's whatever you enter could change wildly based on other inserted code, which is true universally, but it's so easy to happen in HTML, and it's not like it's going to error. It's going to introduce subtle problems. What happens when you have a div inside of a span, inside of a paragraph, inside of a div, inside of all that goodness. Yeah, ideally you would use some structure that uniformly generates things in a reliable fashion. That made more sense there. Gifting food to streamers website. So recall there being a tool to do that, or I'd seen something like that. Might just be interpretive, as in people used it that way. Unsure. I applaud this effort. Free food is free food, man. So then we do another check here. That is, if we're already at max collisions. Which is... this one. We're going to do greater than or equal to, just to be sure. The reason that you always assume that they can exceed a boundary is that it might exceed the boundary. I mean, the cause of writing it or the cause of getting free food? The reason I use greater than or equal to, because if at any point this value managed to exceed max collisions, it would no longer be able to be equal to. It would just keep growing. This is what led to such shenanigans as infinite grenades and Helldivers, where because through a series of kind of special wiggles, you would get to -1 grenades. So if you threw a grenade, you would now have -2, -3, that kind of fun. Whenever that kind of thing would happen, the fail-safe check was, do you have 0? If you have 0, you can't do it. I mean, I am willing to look into such a tool. I can't guarantee I would participate, given that it would involve money and potentially the receipt of money. It would have to be something I'd scrutinize greatly from a contract and security perspective, as one would expect. Okay, so we get the max entity count. That is the length of the incoming collision count buffer. If our X or Y is greater than or equal to that, so since it's 0 based, if it's greater than or equal to, bailout, it would cause a memory access violation. So then we check if our collision count data already shows that we've hit our maximum, bailout. We don't care about collisions on this one anymore. These are early evacuations. We only have to read a little bit of data or look at rapid access supplied data. So if either of these fail, we get out. Then we're going to check, are they active? If they're active, we're doing this one first. Technically, we wouldn't care. But instead of doing a comparison here, it's all the same thing. Let's see. Then we check if they're active. So if they're active, then we're going to compare the mask to the type. We're going to OR them together, which means if there's any overlap in the bytes, it will report true here. Then we're going to check for a collision. So we get the vector 2, we get the squared distance 2, we compare that to the squared combination of the radii. Then if it's less than or equal to that, we've got a collision. Now we're going to try to increment the collision. That means we have to wait in line to do this. That will give us the current index that we would use. If that index is greater than or equal to, if it's not greater than or equal to, so if it's less than the max collisions, so if we can only have 10, the valid indices are 0 to 9. We will then add the collision here. So first, we're going to find out which index to use. Like we mentioned, the collisions array is a max entities collection of max collisions sets of integers representing the indexes of a collision. So, if there are 10 entities and I can have 10 max collisions. It's 100 unsigned integers representing the indexes of things that we're collided with. And we can tell how many there should be by cross-referencing that with the number of collisions. Okay, this should run and not explode. Oh, it didn't explode, but it's running real slow, which means we might be getting an error state. Okay, yeah, we've got an error state. We're gonna set that. Now we're gonna jump over here. Yeah, okay. We missed a close bracket or a I feel like that's a reference. There we go. So if we look at 67, well, approximately 67 here. Open bracket, close bracket. Close, close. Bracket, close bracket, close bracket. Ah, okay. Trying to remember. Marvin the Martian had several different names for a thing that looked like a stick of dynamite. You know, plutonium number space modulator or something like that. $67 again, it doesn't like the ore. I don't want to change that dock. Taking the buffer, we have the data. And off of the in that, so collision mask buffer should give us an unsigned integer, right? Sure, we're not getting a order of operations anomaly here. Nope, still the same thing. We might have to just store it local. Let's try that. Oh, wait. No, this is just wrong, is the thing. It's just wrong. Let's try again. Okay. So it's better, but always assume that your data can be out of bounds. Is that going to do what I want it to do? Because these are both greater than 1. Is there a proper bitwise OR? Doki Doki the Gathering / Yu-Gi-Oh! Literature Club. I heard that the folks behind Doki Doki did another one. I think I saw it listed on Steam. Given that they want you to mess with file system, I don't trust them not to pull the same things that One Shot did and potentially reveal, PII and similar. Syntax. Okay. Single pipe. Oh. $70 according to this. Build. But I can't do this equals that, because what I need is to do a bitwise OR of these two types. I want to get collision type or 0 out of it. Which, I mean, in theory... Syntax. Okay, it claims they're not implemented, but that's on a different site. This one. Alright, how are we going to do this with a mask then? It doesn't seem to like this. How are we going to do this? How are we going to do this? Example of somebody brute forcing that. Atomic XOR. Don't want to do an actual atomic operation on it. Like, won't that block during it? reading the full syntax here. Okay, so we'd have an output value. All right, this is going to be a legibility thing that we're going to do. Okay, so this is a value that will be modified. It's going to take the current contents of this. It's going to do an exclusive OR with it, so it's going to render it down into... it's going to take the value in here. It's going to do an exclusive OR. So if the bits for this one need to be contained in the bits for this one, or else we're going to get 0. Otherwise, we will get that back. So, an exclusive OR of 2 and 2 is equal to 2. But an exclusive OR of 1 and 2 is 0. Because the bits don't line up. Assuming this works how I think it works. So I can't mess with the mask. I can't mess with the actual buffer value. Because that would distort it. It would turn into 0. like it's stuck. There we go. Well, that's weird. Okay, okay. There we go. This side. Oh, that'd be chunking. Just double checking to make sure we're not messing something up here. Through this. Preparing everything. Okay, no, some of these are off. So I don't actually need these, but you know. This position X bytes not exist. Oh. The thing is, it at the moment it shouldn't even be running at all, because only a very limited set are set active. Radius needs to be the same way. Just cleaning up some more stuff. Let's run it over on the Godot side and see if we can spot in the metrics what's going on. And okay, well, that's going to cause a problem. We are overutilizing the GPU. Something off here. Just going to run it at smaller numbers and see if we've got that as our problem. Okay, something about the number of them. Getting that many. Lifespan, that's why. And Stroby when the slimes are managing to weave amongst the yarn balls there, isn't it? is our critical threshold, you know? Well, that crosses it, that's for sure. Trying to figure out how we do it. The number of different ways I have tried to get the system to ignore that onboard card. I keep occasionally having some more processor-heavy games complain that the Intel drivers are out of date, despite the fact that none of them report actually using it. They just see it there. All right. Okay, so this is our snag point here, is figuring out how to optimize this down. It's a quandary. It is certainly a quandary here. Because I think we're onto something as far as the raw structure. But this still starts to drag, and the thing is, we were getting further before. At least I feel like we were getting further before. All right, let's try some different numbers here. Yeah. Yeah, we might need to look at re-architecting how we're recording these again. We could shift to how you were assuming it would work before, is the like limited total collisions per physics frame. That would be a way that we could go about it. We ultimately might need to. So let's try that before we wrap up today, huh? That's our benchmark. We want to hit that. We want to be able to load that. It should all be the same. Yeah. So we have 2 max collisions. We have the total number of collisions, and we have a collisions per. Just for the time being. Yeah. Oh. Well, thank you, Parakeet. I appreciate it. Okay, let's at least try to get this structure in place here. Track this needs to be 2. Then we're going to need another variable. We'll tack it on to the end just so I don't have to increment everything. Oh no, but it's just a shared variable. It's not actually a buffer. That up real quick here. The varying type. It's not a uniform because we don't pass it in. Okay, we're going to pass it in as a buffer. A buffer we don't care about changing. We need to make a new buffer variable. Total collisions buffer is just a int, essentially. Clear it, and now we need to set it up. Still a storage buffer because we want it to be something that they mess with. It would still... Still going to initialize it as... Syntax. Unnecessary. Store this byte array off. Set it, then we do length. Bytes. And we are always going to reset these bytes. We never care about what's in this. Out. Always resetting it to 0, and we never retrieve it. So then when we are initializing our collisions data, it's not max entities times max collisions. It is just max collisions. Yep. And then in this, we need to get another buffer here. We need to make sure that we are getting it marshaled correctly. Okay, so we create the buffer, and then we are going to actually add it to the uniform. This is another little bit that we could this whole sequence we could clean up here. Because we're duplicating code over and over in this. Should not do. Got that added in. All right. That's still the same. Okay, so if the total collisions is greater, then we're going to greater than or equal to, we're going to stop there. Then now we do an individual check. We're going to check and see if this one, for its collision count, is greater than or equal to settings buffer. Max collisions per entity. Okay, so we increment both of these when we find a collision. There's a risk surface here, though. Because if a single entity starts to collide, okay, I'm going to do an atomic add on that first. We don't care about that aside from a gate. In theory, this could eat an extra collision. It's not really a problem. Atomic add on total collisions buffer, total collisions. I think there's a different syntax I could do on this. But I'm not sure. Like, I might be able to just use that variable as something, but we're going to roll with what we got. So we did not enter unless there was space for that entity. If we get to here, we still want to check. Settings. Okay. So we've added an extra check here. So the entity level collision count is no longer an output. Actually do care about that other one. Anyway, entity collision count is something that we're going to reset that's purely for operations. We go through and we say, are the indexes in bounds? That's our first check. We just want to make sure nothing blows up. Then we're going to check total collisions. If we're out of total collisions, then just stop. We're going to bail out of all of them. Then we're going to check, does this entity have enough collisions left? So effectively, we're saying right now there can be 100 collisions and only one per entity. This is happening every other physics frame. There's plenty of time for entities to detect other collisions. Now, we don't want this to happen. We don't want to limit ourselves this much because we don't want entities to phase through each other, and we don't want dead iterations to happen. We're probably going to make use of inactive if an entity is going to reject collisions entirely, but we still need to deal with overall. It might be possible that it's rejecting some types of collision, but it still wants to check for them. Lots of variables there. But anyway, so each entity gets a limit of collisions, and we only parse so many collisions per frame. So then we check, are they active? If both are active, we do the mask check. Then we do the full, is it going to collide? If it's going to collide, we check the entity collision. We increment it and check it. If there's not room for the entity to have this collision, we're going to bail out. This is actually needs to be... Yeah. Right, because this will be the last one. So if it fits within the number of collisions for that entity, when we've detected one, then we're going to go in and we're going to add one to the main collection. This is probably a thread safe risk here. Because it's technically possible for two of them to get past this simultaneously and start messing with this. But that's what this check is for. So we might miss a collision or two. But you still have to get past here. So one of them will get the short stick there. All right, let's. Okay, we have shader issues. Piled. Okay, running smoothly. Let's bump it up. And let's get them twirling to maximize stress on the system here. Again, we are producing 18 per physics frame right now. It's 54. Still climbing. Don't look like much, but a lot is happening, and it's good. In theory. GPU is not exploding. The little ears peeking out of the vortex there at the center. Need to go higher. Getting frames per second. There we are. Very nice. All right, folks. We've made progress again. We have made progress again. Oh, well. I'm going to have to figure out what all these errors were that were going while it was running, but... Okay, I had a buffer overflow thing, so it was trying to write past the end of memory. I need to change some of that logic. Yeah. Those should be getting checked. Oh. Okay, I know what was happening. But anyway, we'll address that next time. So we've got the raw collision check in there. The next thing is going to be actually getting this data into the system. So keeping track of like entity IDs, merging them into the system, getting the collisions. And when those collisions happen, just like with the base one, we report that and remove them. And we'll see how that goes. So next time, we might actually get to see the collisions in action. We'll see. But I do want to thank everybody for joining us today. Another thanks to Parakeet for the bits. Always appreciated. Now, if you like what you see and would like to see more, remember to like, follow, subscribe, all of that good stuff. It does help the channel grow. And with all of that said, I hope the rest of your day is good, and I will see you next time.